We've made it to the final lesson. So today we're going to continue with the law of sines, this time finding the angles. And I want to begin this lesson by first giving you a unit summary. So here's what we've done throughout this chapter. We began by talking about similarity, learning about ratios and proportions, and then about dilations. After that, this kind of was the segment into introduction of triangles. Then we had a new objective, and our objective became the question of solving right triangles. And we were able to achieve that by learning a bunch of theorems and strategies that would help us either solve for the missing length or solve for the unknown angles. We also did some applications. And now we're going to end this unit by exploring the topic of not only right triangles but any triangle. And we're ending the topic with the law of sines. So let's get into today's question, and that's going to be to find the missing angle. And here's a review of what the law of sines says. So basically you get the angle and divide it by the side that's across from it. So here we have angle A, so we can get the sine of A, and divide it by A. That's going to equal the sine of B over the length B, and it also equals the sine of C over little c. So let's take a look at some examples, beginning with example 1. So today we're going to find the measurement of angle A. We're going to give the answer to the nearest degree. I'm going to make I'm going to rename it as theta. So to apply the law of sines, I can get my angle, and I can get the sine of it. So I'm going to get sine of theta, and that's going to be 220 because that's the length across from it. That is going to equal, and now I have this angle 76, so I'm going to use that. It's going to equal the sine of 76 over the length of 28. So sine of 76 over 28. We can solve this proportion by cross multiplication. So I'm going to multiply 28 times sine of theta, and that's going to equal 28 times sine of 76. And I made a tiny error. It should be 20 times sine of 76. So now I can split the equation. On the left hand side, I have 28 times sine of theta. And then on the right hand side, I can multiply 20 times sine of 76, so I can input that in the calculator, and I'm going to get an approximation of 19.41, so rounding to the nearest hundredth. Now I know here I put a nearest degree, but I'm going to switch it to the nearest hundredth, and that's what it's going to say in your assignment as well. So now here the objective is to isolate theta, and if I want to achieve that, I first have to get rid of here this 28. So I'm going to divide by 28 on the left, and whatever I do to the left, I gotta do it on the right. So 28 over 28, that's just 1. So we get 1 times sine of theta, and that's gonna be approximately equal to 0.69. So 19.41 over 28 is approximately 0.69. So now here we get sine of theta, because 1 times sine theta is just sine theta, approximately equal to 0.69. To isolate theta, I'm going to have to take the inverse. So compose the left, compose the right by sine inverse. So here I have sine inverse of sine of theta. And I have sine inverse of 0.69. That's approximately equal. On the left hand side, the inverses cancel out and we get 1. So theta's isolated. 1 times theta is approximately equal to sine inverse of 0.69. We can input that in a calculator. We get approximately 43.63. So theta is approximately equal to 43.63, and that is the measurement of that angle. Alright, so pretty similar to what we did yesterday. This time we're just applying the inverse trigonometric functions, but More or less the same process. So let's do one more example before you try these out on your own. So for example 2, now we're going to try and find the measurement of angle C. So here I'm going to label C as theta. And theta points to 17 inches. So if I want to apply the law of sines, I can get sine of theta over 17. And that's going to be equal to, I see that I have another angle of 94. So 94 points to 32 inches. So I can do sine of 94 over 32. Now I can apply the cross multiplication since I have a proportion, so I get 32 sine of theta equal to 17 times sine of 94. And let's split this up to differentiate the left from the right. And here I'm going to get 32 sine theta is approximately equal to 17 sine 94. If I input it in a calculator, I'm getting an approximation of 16.96. And now here, I want to isolate theta, but first I got to get rid of this 32. So I got to do the inverse operation, and the opposite of multiplication is division. So I'm going to divide by 32. Whatever I do to one side, I have to do it to the other. On the left, 32 over 32, that's just 1. So I get 1 times sine of theta, approximately equal to 0.53. So I have sine of theta approximately equal to 0.53. I want to isolate theta, so I'm going to have to compose the left hand side and the right hand side by sine inverse. So here I get sine inverse of sine of theta, and that's going to be approximately equal to the sine inverse of 0.53. On the left, the sine and the sine inverse cancel out, so theta is going to be isolated. We get 1 times theta approximately equal to 32 degrees. So I get that theta is approximately equal to 32 degrees. And that is the measurement of this angle. Alright, that's it. So finish the assignment, and I'll see you next time.